Hi guys, this is Tobias DL3MHT with another short video. I tried to cut it down to a minute and failed miserably, so this will be a regular one. Let's see if I manage below 10 minutes. So what are we doing here? Another end-fed half-wave transformer experiment, and the question that I was wondering, when you wind the transformer the classical way, you basically wind 7 turns, then you do the direction change, and then you wind another 6 or 7 or 8 turns to give you the 1 to 49 or 1 to 64 transformer ratio. So I was wondering, does the turn where you change direction count as a full turn, or is it only partially effective because we are not touching the ferrite core? So that is what I tried to find out. So in order to do that, I built 2 to 15 transformer with a tap, so no twisted wires, but just for fun. I don't think it makes any difference. Here we have a variable resistor, and when I tweak this, you can see on the nano VNA, I can get the SWR down until, at some point, maybe like this, I have a minimum around, 10 megahertz. Let me scroll. Yeah. You can still, I could zoom in and spend more time to find a minimum. The problem is, if you do this, desolder the resistor and measure it, then you get a transformer ratio of about 1 to 90. So this gives you around, 4.5 kilo ohm when you set it up like this. So as that clearly doesn't work, and the real transformer has the famous 100 picofarad compensation capacitor. Let me clip it on. Holding the mobile and filming and talking in not my mother tongue. Challenges. Come on. And so now it's on, and you immediately see the change here on the SWR curve. And now I can tweak it a bit further, and you can basically set it up so that, it's not, you don't get it completely flat, but you can tweak it to a minimum where you don't go above SWR 1 to 125 here in the middle. So maybe set it up like this. And now we can desolder and see what transformer ratio we got here. 2830, 31, 35 ohms. It jumps around a bit, which gives us, for divided by 50, gives us a transformer ratio of 1 to 56.6. And the theory is 2 to 15, which is 1 to 7.5 winding ratio, so 7.5 squared gives us 1 to 56.25. So for the quick and dirty way to measure that, I think we're pretty close. We expected 1 to 56.25. We got 1.56.60. Well, the ferrite core has tolerance, I think 10 or 20%. And it depends how you squish, how close you wind it, how spaced you wind it. So, right, a lot of parameters. So now, as a comparison, I don't know the result yet of that experiment. Maybe we get something completely bogus. So I will change the turns now here. Basically unwind 7 or 8 turns, introduce the direction change and wind it again. And then we'll measure the same with the turn, and then we compare the differences. I don't know if we will see anything, but that's the experiment. Okay, and here we are back. The transformer is changed. I already clipped on the capacitor. So let me try to find the minimum again. Do it in maybe a similar way that I did it before. So try to get below 1 to 1.5. You already see a bit of a difference. So I don't know. Maybe like this. And yeah, desoldering again and see what we get. Okay, so yeah, the resistor is desoldered. I'm measuring 2522 ohms. Then we can do the calculation again. 2522 divided by 50 gives us a ratio of 1 to 50.44. When we take the square root of that, it's 127.1 squared. And if we multiply the value by 2, it basically tells you that our winding ratio for this winding type is 2 to 14.2. So that means that change of direction here doesn't count as a full turn. It counts, well, with that specific ferrite and, you know, with the way I measured and with all the dodgy setup, yeah, it only counts for 0.2 of a turn. And in comparison to that, I did the same with the other variant. So we got here 2830 divided by 50 gives us 56.6. Square root of that is 7.523. Multiplied by 2 gives us backwards calculated ratio of 2 to 15.046. So pretty good, I would say, yeah. So there you go, side by side. When you count every time the wire crosses the inside of your ferrite core and you wind 2 to 15, effectively when you have the turn, it only counts for 0.2 turns. And when you do not have the turn, then obviously it counts as a full turn. So pretty close to 2.15. So I'm a bit surprised that I'm so close to the theory. So probably I made some major mistake. Please put some comments below and yeah, until next time. Thanks.